Let's quickly take a look at mesh analysis, which basically deploys KVL. Now, there are a couple of things I want you to understand when it comes to mesh analysis and KVL. All right, very simple, straightforward. In this question, you are being asked to figure out the voltage across 6K resistor. When we say we are doing circuit analysis on a given circuit, that basically means that we should be able to comment on and figure out every single parameter for the entire circuit, whether that is current through this 2K resistor, whether there is voltage drop across the 4K resistor, whether that is the total current provided by the source, whether that is the power consumption in individual circuit elements. Does it make sense? This is what circuit analysis means. All right. So not a big deal if somebody is asking us to figure out the voltage across the 6K resistor if we know what we are doing. Okay. So here's the thing. Just two steps that you need to remember, understand, and properly apply for mesh analysis, and you'll be set. Number one, the directions that you set, okay, loops that you set must be identical. What does that mean? You cannot have this guy clockwise and this guy anti-clockwise. Is that clear? If you have three loops, all three loops should be counterclockwise or clockwise. All right, that's the one thing. The second thing I'll have to explain when I write the equation, and it has to do with the center branch, the common branch. Okay, so don't mismatch these directions. They should all be the same. All right. And how to deal with the center branch depends on which loop you are writing, which I'll explain you shortly. So if I'm writing loop number one, and notice that I'm assuming clockwise directions over here, I1 and I2. So if I'm writing loop number one, guys, okay, that basically involves this, correct? I1 and this. Now here's the thing. What did I tell you about resistors? KVL is sum of voltage gain is equal to sum of voltage drop, correct? So if I encounter current going through the 2K resistor I1 times 2K, is it going to be a voltage gain or a voltage drop? Resistors always, always, always voltage drop. 2K times I1, voltage drop. 4K times I1, voltage drop. Okay. 6K times, if you look at the center branch, this is the tricky one. We are writing the loop equation. This is the second thing I wanted to explain. Loop equation for loop number one, correct? Loop equation for loop number one. What we are going to assume is that I1 loop current 1 is the dominant current. So when I am figuring out the current passing through 6K, okay, notice that I1 is entering from the top, and if I complete this loop for I2, I2 is entering from the bottom. Can you see that? Okay. Since I am in loop 1, I am going to assume that current I1 is the dominant current. Okay. So I'm going to write this as I1 minus I2, and the net direction of current flow will be like this. Okay. So the delta I that is flowing through this is still following the same direction that I1 is, because I am writing it for loop number one. And then I'm going to multiply it with 6K. Okay. And how do we so that's basically the key. Whichever loop you are in, that will be treated as a dominant loop current. And when we write for loop number two, I'll show you how that changes. Now, the other thing is a passive sign convention. Notice that I1 enters the positive terminal of the 12-volt battery and it is leaving the negative terminal. So how do we tackle that? Should that be voltage gain or voltage drop? If the current enters the positive terminal of a voltage source and leaves the negative terminal of the voltage source, it is always a voltage drop. Okay. I find students writing 12 volt on the right hand side saying that, okay, 2K resistor, 4K resistor, 6K resistor, drop, drop, drop. But the 12 volt, because it is a voltage source, better be a gain. Because otherwise, why would you have a zero over here? Should not balance out, right? Wrong. All of these voltage changes for loop number one are in fact voltage drops. There is no single voltage gain here. Does it make sense? So these are the fine mistakes that students end up making. Now let's focus on loop number two. When I'm going through loop number two, I1 is gonna come into play, but in the middle branch. So I have I2 times 4K drop. Current times resistor, always a drop. I2 times 6K drop. Current times resistor, always a drop. I encountered the negative terminal of the battery, this current I2, and it's leaving from the positive terminal. When the current leaves the positive terminal of the battery, that's a voltage gain. So I can either write that as minus 12 over here, or I can say that there is a 12 volt gain because when I move this over here, it becomes plus 12 volt, right? For loop number two, we actually have a 12 volt gain because the current is leaving the positive terminal. See? These are the fine details that you must understand if you want to score good points on circuits. And circuits carries over to electronics and power in FE electrical, even in linear systems. And circuits carries over 100% into P power. Okay. Now let's handle the 6K resistor. When we are living in this loop, loop 2, we are writing it for I2, right? If the current has to take this direction, then I2 must be the dominant current. We're going to write this as I2 minus I1. Can you guys see this? Okay. That is a key point to understand when you're writing KVL for mesh analysis. How many equations we have? Two equations. How many unknowns we have? Two unknowns. Can we solve it? Very easy, very simple. Two equations, two unknown, and we can go about solving it. Now, interestingly, you find that when you go punch it in the calculator, do hand calculations, whatnot, I1 turns out to be negative. Does that mean my answer is incorrect? No, it just means that it is 10 by 13 milliamp, but the actual direction of I1 is this. As simple as that. Okay. We were interested in V naught. V naught was simply the voltage drop across 6K resistor. The voltage drop across 6K resistor was I2 times 6K. As simple as that. So we've unlocked this. On-demand program, FE electrical. So you can see mathematics. Okay. I have lots of lectures, quizzes, lectures, quizzes, lectures, quizzes. So for each and every part of the specification item, algebra, straight lines is divided into a dedicated lecture and then a quiz. And within the lectures, you will basically find downloadable PDFs containing the key formulas, equations, and whatnot. Then you can use as part of your notes. And then when you go through the content, there are detailed explanations. I go through the conceptual overview and then practice problems and then the quizzes with detailed solutions. And this is just math on the left-hand side, right? So it's streamlined. It's a one-stop shop basically with all the resources that are available to you. And then I have time mini exams at the end. We were talking about circuit analysis, right? So let's jump to circuit analysis. So right here. So I have KCL, 19-minute lecture, calculator tutorial, explaining you how to go about solving the multiple linear equations, additional practice problems on KCL, then deep dive on KCL, right? KVL, I have a dedicated lecture, additional practice problems, series parallel equivalent circuits, Thevenin theorem, additional practice problems, deep dive. So this is all circuit analysis, right? I mentioned about computer sections earlier. So let's just jump ahead to computer sections. Even if you have zero background in computers, check this out. In computer networks, I have about 20 plus lectures. So if you're starting from zero reference, you can go through this content and rest assured that most likely you're going to be over prepared, right? And if you are weak in digital systems or any topic for that reason, computer systems, if you haven't taken computer, if you haven't taken software engineering or software course, then you can go through a bunch of these lectures as well. And then a full and computer simulated practice exam at the end. As far as the live training is concerned, the live training is starting on January 11th. And I have lots of students who are enrolling right now with the goal of covering at least a couple of sections before the live classes start. So I review the big 5 topics up front in the first 5 weeks. And in a fairly short period of time, by 30th of March, you're going to see that the entire 17 section for FE electrical and computer exam will be covered. And as far as the live training is concerned, the expectation is that students are basically going to be working through the topics of the week that I assign, lectures and quizzes, they complete them. I put together focus summaries for them that they can go through at 1.25, 1.5x. I give them weekly homework assignments on every single topic, and then study guide they can utilize as well. These are the crash course summaries. And then during the class, then we basically go through all of these topics in detail. And over a 12-week period, you're going to see that we'll be covering all the exam sections in a fairly efficient time. I also have a very active community. So as far as the support network is concerned, if you have any questions, you are not going to be stranded. You can always ask questions over here. You can, let's say you're operating in mathematics. If you have a question, you can post the question in mathematics, and you can see that students are asking questions all the time, very frequently, and they're getting responses from my teaching assistants and from myself in detail. Okay, so this student asked question 3 hours ago at 9:14 a.m., right? And the teaching assistant responded back at 11:13 a.m. with a detailed response. Okay, and again, same thing over here, and then I get detailed response over here. And this is broken out section by section, topic by topic. And even over here, you can see tons of success stories. Students are posting every Wednesday when they pass the FE exam, when they pass the PE exam, right? Yeah. And then as far as the P is concerned, I have a separate categories. You can, whether you're operating in general power engineering, measurement instrumentation, whether you're operating in circuit, section 3, section 2, very detailed responses. And you will never be alone in terms of your preparation. As far as the P power program is concerned, let me just quickly show you. Remember I told you about the instrument transformers, that they are not even mentioned in the reference handbook. So when you check this out, part 1, instrument transformers, conceptual corner quizzes, okay? And then you have part 2, part 3, part 4, part 5, detailed explanations, multiple quizzes, and so on, okay? Check out the codes and standards section if you haven't already started your preparation. As I mentioned earlier, about 15 to 20% of the exam is contained there. So this is section number 1, by the way, on the left-hand side. And these are not Mickey Mouse lectures, 34 minutes long. Some of them are 1 hour long, 18 minutes, 20 minutes, right? So NEC part 1 contains an overview, part 2, conductor sizing, part 3 is overcurrent protection, and then you have wiring, then you have junction box sizing, and so on and so forth, okay? And at the very end, when you come across protection, which is a topic that's missing in the reference handbook, tons and tons of details on that as well. And the live training program for the P power, same story. Starting on 11th of January, we're going to wrap it up 30th of March, and we're going to sequentially work through all of the sections, all of the topics, and basically get the job done. Typically, students schedule their exam within 3 to 4 weeks of the completion of the live training program if they're making use of the bundle. And that gives them the opportunity to do the practice problems, address the weak areas, do practice exams, sample exams, and gives them an idea of, opportunity to consolidate their learning.